All right, everybody, we are going to move on now. We just finished up the classes and inheritance playground, which is, as you can see on my screen here, um, and I assume my screen's being shared. I can't really tell. You can see my screen, Jomar?
Yes, I can see
Okay.
it.
All right. I just want to make sure because I hit the share panel and it's trying to share again. So I apologize for this awkward beginning to the video, but I just want to make sure I'm doing the right thing. But we are going to move on, and you can see my Finder window in the on the right side of the screen here. We're going to be in Unit 2 and then Section 5, which is collections. So we are going to work on the collections playground. If you want, you can take that classes playground if you're all done with your screenshots and whatnot that I require for turning this in. So I'm going to close that one. I also have the teacher's version open on my other screen, which I'm closing. And then I'm going to do, well, my collections one, it looks like it's already open. Fantastic. And this is the student version. But I am in my, or I should say on my other screen, right, and I'm getting there on my other screen. I'm opening up the same thing, the teacher version, just so I can have basically cheat sheets here and a guide as I'm working to make sure I give you guys all the correct code and everything. What I would like to do once again is I would like to bring the book back up on screen, and I'll move that back over so we can just kind of see where we are in terms of the book. At this point in the book, it gets pretty vague and it kind of like leans really heavily on the playground and on the keynotes, right? So we went through this one last time, and I'd like to do the same thing with collections. It's a little atypical for me to actually lean on the keynotes a little bit, but because they have such a lack of material here in the written part of the chapter, they really tell you what you should be learning, and good luck basically is kind of the approach. So let's just take a really quick look at this. When we start working with collections are really important, and you can see here that they start to break the collections down into arrays, dictionaries, and sets, and there's like three basically different types, but the concepts are really important. Also, the concepts transfer to other languages. In some cases, we call them exactly the same thing or similar names, and often they operate very similarly too. All right, so let's take a look at the types that they're referring to, and usually when we start to learn about this thing called collections, right, and that's not what I think of as the primary term for this, but Apple, and the fact that they're kind of basically inventing a new language here to make it easier for people to code, they're using this as the higher level concept, and I think it's pretty correct, because when we have collections, really the way to think about it is collections of information that is similar, right, and they're organized together and travel together. So the most common type is the array, right, and that's like where we basically, if you're a Python person, you think of this as a list. If you're a regular programmer, you think of it as an array, but it's basically one name memory location that holds a bunch of different values. So for example, if I create an array called names, right? And the data type for names is a string. And you notice, how do we know that we're defining an array? Because we're putting square brackets around it. That's how, right? And we're saying that it's basically an array structure with the capability of holding strings. And of course, we can populate it right off the bat, so we can drop strings into it, comma separated values. And then we can refer to all the contents of the array using an index number starting with 0 for the first entry. So Anne is in position 0, Gary is 1, Keith is 2, right? Now, we can also define an array like this, and this is kind of interesting, without declaring the data type. And the reason that that's allowed is because we're populating it immediately with the correct data type. And notice we're not mixing data types here. This is all strings going into this array. So this approach works just fine too. I think generally the preference is to type it, even if you're feeding in values, but hey, there's kind of, rules and not rules. Now we can also do something like this. So it doesn't have to be just strings. It can be numbers. In this case, you notice that they're all counting numbers, positive and negative. So this would be an array of type integer in this situation. We can also have it cast a very specific type. And we haven't talked a lot about the different integer types, but there's more than one type. So we generally use the generic int. But there's other ones that are like int 8, 32, et cetera, et cetera. And those all have to do with how big of a number they can hold. Generally, the smaller the number, the less they hold. And so it's more memory efficient. For example, if I have an array of int 8, right, which holds smaller numbers, so that every time I have a position to store a number, I'm not using tons of memory that I don't need because I'm just putting the number 1 into it, if you catch what I mean. So that's regardless, the data type goes here. So you can do it with the data type or without, right? Now, if you're declaring an array, so look at the example here. So we say numbers has 4, 5, and 6 in it. Then we have methods that come with the arrays. So like a common method for array is contains, and it just checks to see, hey, is this value part of this array, right? So it says if numbers dot contains 5, so it goes in, finds 5, and if that's true, then it will output it, right? So arrays come with methods. Contains is a real simple one, but actually arrays come with lots of different methods that we can do some pretty powerful things with it to save us, the code of writing it. Like how would you write the code to check to see if a number is part of an array? Well, we haven't gotten to that yet, but you can write code to do that. So you could just go array position, one position at a time, compare it to a value, and then if you find it, you can trigger true, right? But somebody decided to already build that for us, so we go with it. All right. There are different types of array types, and I do want to kind of point out like how we can kind of initialize these. So I want you to look at these really carefully, and they're kind of functionally all the same thing here, right? And sort of kind of not at the same time, but you can do the top approach, which is I guess the first one we looked at, which is you name it, you declare that it's going to be an array with the square brackets on the left side of the equal sign, right? Like here, right? So we know it's an array just because of those square brackets. And then, well, we don't have to give it values, but if we set it equal to somebody, right now it's empty, right? We can also do this approach, and this is more of what I think of as an array list, so we get kind of into like this weird kind of like computer sciencey kind of like definition area. But this is an approach too, where instead of using the square brackets, we're actually using the word array, right? But notice on the other side of the equal sign, still empty square brackets. You could put stuff in there, but just a different way. Another approach is to skip the colon and the data type and the array designation on the left side of the equal sign. And you just say my array equals, and then notice square bracket int, the data type is there, and parentheses, which means construct. This is a constructor approach, kind of like we do with classes or structures. So any one of these can work, and is perfectly valid. I think the top approach is the most preferred, right? Generally speaking, but there's circumstances at times where we might want to use one of the other approaches. Swift is making sort of an attempt to kind of be flexible like Python is, but caution, on the different approach. Now, what's kind of fascinating here is that there's, kind of like building upon the fact that we have kind of, array structures that have methods that are already attached to them. If you use the last approach from the previous slide to create something, you'll notice that that last approach has probably a class structure of some sort or a reference type structure that has built into it variables of like repeating and count, right? And so I can run those. And in this case, I'm actually setting the value of count to 100 and repeating to 0. So is anything repeating? No. how many are there 100, and then we can run that as a property, right? Because it's really what it is. It's like a variable inside that integer array structure where we can count how many elements we have. So this is a really common one to ask, like whatever your array is, how much stuff is in it? How many positions are there? None? 100? What is it, right? And we also have the capability of running these properties that are kind of built in once again, where, and notice, this one's a Boolean just because of the way it's asked. Is this empty? Is it empty? So it's a true or false, right? So we can use that to run logic. So what they're really saying here is like, I can check to see if an array is empty. And if it's empty, I might put up an error message. If it's not empty, I might put stuff in it or pull stuff out of it, right? So just kind of the approach. If you look at how to access specific values, and I think you guys probably remember this, so if you put in an array of strings and I want to take an out of there, I would go to names, position 0, starts with 0, 1, 2, etc., and then put that here, and you would see an, right? So you can see that I could pull that from position 0. Really, the most important thing is remember that the index values are numbered and the computers always start counting at 0, right? So always keep that in mind. If I was to look at what's in names, position 1, right? And in this case, really what the syntax is saying, right? Single equal sign, it's an assignment statement. Whatever's on the right side of that equal sign is getting stored in position 1 of the names array. So Paul will replace Gary. This is position 0. This is position 1. So now the array really is Anne, Paul, and Keith. So when I print it, this assigned a new value to the middle position and it's stuck, right? So we'll kind of do all of that as we're kind of doing our exercises. If you want to add something to an array, so if my array starts out with just one name in it, right? How do I know it's an array? Square brackets, right? If I do an append command, that adds to the end of the structure. So after this statement, my array now is Amy, comma, Joe, right? I can also append to an array. This is really bizarre, using plus equals. So I can also append, this is actually an append command, Keith and Jane. And so first I added Joe, then I added Keith and Jane. Then if I print it, I get the whole thing. So two very handy techniques for adding stuff to an array. Okay, so very important, I think, helpful, if you will. We can also insert values. Okay, so we start with an array here where we have 4 values, positions 0, 1, 2, and 3, right? 0, 1, 2, and 3. Here we're using an insert command, and where are we inserting Bob? At position 0. So we go to position 0, push everything over to the right, and put Bob right here. So now when you print it, you see Bob's in the first position, position 0, and then everything else is pushed over. So Amy, which used to be position 0, is now 1, 2, 3, and 4. If we run a count on this, the count is 5. There's 5 items in the array. So those are kind of helpful. You can also remove, right? So you can actually use the remove command with a specific position. So if I remove at position 2, right, 0, 1, 2, I'm removing Chelsea. Then, right, and notice it's already telling us what it is, right? And then if we remove the last item, which is Dan, and then we go to print it, well, Chelsea and Dan are gone, but Amy and Brad are still there. So that's helpful too, right? So you can put stuff in an array and you can pull it out, and you can pull it out or put it in exactly where you want to, right? Or need to, depending on what your thing is. There is also a remove all command. So sometimes you use an array as a temporary holding place for information, and then remove it all and then put other stuff in there. Maybe it's just to process it or sort it or add it, or who knows, right? We don't know what the purpose is, but you can do that. So these are all remove at certain positions, remove last, or remove all, and they all work with arrays. Right. Now, kind of another interesting thing is you can take arrays when they're, and I think the caveat is when they're of compatible data types. So like if I have a first array and it's all strings and a second array and it's all strings, I can add them together and it forms a new array that you can work with. Now, this is kind of weird, but arrays are objects, right? So if you think about them like as a thing, as opposed to individual pieces of information, I can take the entire array and put it into an array. So in other words, here I'm creating array 1, then I'm creating array 2, and oh darn, I didn't want to do that. So I'm going to go back in there and click my way back to where it was. I accidentally clicked on the screen, which takes me to the next slide, and then I can't go backwards in this format. I apologize. Pretty lame, but that's how it is. All right. So we created one array of numbers, another array of numbers, and then here I create another array populated with arrays. Now this is really strange, but conceptually what we're really doing, and I'm gonna draw on the screen for this, is if I take the first array, so in this position I have 1, 2, 3, really bad drawing numbers here with a pen on screen, and then this array contains 4, 5, 6. Really what's happening is when we have an array inside of an array, we're actually kind of forming a table. It's kind of like going 1, 2, 3. My next array is 4, 5, 6. And we're kind of really implying like a row and column structure here. So it becomes a 2-dimensional array at this point, right? So the one larger array contains an array in its first position, and then another array in its second position. So if I wanted, this is really weird. So this is what they're trying to like explain here is the syntax for accessing the information. Then how do you do this, right? If the first array 1 is in position 0 and this one's in position 1, you could kind of like think of it as an index value for this row, right? And 1 becomes an index value for that row. And then if I want to get to the individual positions, once again, we go 0, 1, 2. Once again, I apologize for the bad penmanship here in the Zoom drawing tool or whatever. So if I want to get to this position, this is in row 1, column 0, right? So, all right. So here they say, let first array equal container array 0. So if I just look at position 0 of container array, it's this that I'm looking at. I get the whole darn row. But if I want to look at just the first element in that first row, notice the syntax, 2 square bracketed numbers. So that means I go to row 1, column 1. So that digs into this position, right? So I think this is really interesting. Like conceptually, right? When you first encounter this as a programmer, you go, oh my God, why on earth would you ever do this? Right? That's the kind of stuff you say to yourself. And then you start to think of reasons, because if I wanted, for example, to create a game of, play with me here, a game of tic-tac-toe, right? You could think of this as an array that contains 3 arrays, each with 3 positions, right? So we would have row 1 or 0, 1, 2, and then column 0, 1, 2, and then this would be 0, 0, this would be 0, 1, this would be 0, 2, this would be 1, 0, et cetera, et cetera, et cetera. And this is kind of the conception here. Now, this is a 2-dimensional structure. A 2-dimensional structure, and if you're not thinking about this, this is like a table in Excel, right? So when Excel is putting information into its cells, it's exactly how it's storing it. Isn't that kind of weird? Right? So when you have rows and columns, they're really just arrays inside of arrays. Then you want to go down the rabbit hole one further, right? Yeah, you can have three-dimensional arrays. If you compare it to a spreadsheet, well, each spreadsheet has rows and columns, but an application like Excel or Google Sheets or Mac Numbers also has the capability of having separate tabs inside each spreadsheet. So that there's your third dimension. You know, on the higher level, it's which tab you're on. And you know what? Conceptually, you can go as deep into like how many arrays deep you go into like this whole thing, as deep as your brain can handle it. Most humans can't really think beyond 2 or 3 levels of it though, right? Yeah, so but you come up with conceptions for why this works. So I think it's kind of an interesting thing. Once again, the usage is really dependent upon what you're doing programmatically, right? All right, so that was arrays. Arrays are put into this data structure or collection, and each thing you put into a spot has an index number, right? So you can find it, right? Position row 0, column 1, whatever, right? You can find that. There's a different type of data structure that we call a dictionary. Now, interestingly, if I'm working in Python, right? So a lot of people end up working in Python who take these classes. They also call this identical structure a dictionary. In other languages, so if you learn how to do PHP, or I think in Java and most C-style languages, we call dictionaries associative arrays. So in other words, they're kind of like an array, except they don't have index numbers. We throw the index numbers away, right? And say, all right, we're not using those. So what are we using instead? Well, we come up with what we call key value pairs. So all the information, instead of having an index number, has the first value in a pair, which is the key. So I don't know what these things represent, but here there's Richard is the key, and the value we're storing with it is 500. It's an integer. Okay, maybe this is his paycheck or savings or something, right? So if I want to figure out how much savings Richard has, well, I look Richard up. Well, how do I look him up? Well, I look him up by Richard, not by position 0. Now think about that, right? Like if you pick up, so why do we call it a dictionary? If you pick up a physical dictionary, why do you do that? Because you want to know how to spell a word or what a word means. So how do I know what, a specific word means? I find it in the dictionary. I look it up alphabetically, or however I find it. And then once I find the word in the dictionary, I look at the definition. So the word in the dictionary is kind of like the key. The definition is the value, right? And in this example, they're using keys that are names and values that are numbers. But in reality, they could both be numbers, or they could both be strings, or the number could be over here and the name could be over there. It doesn't really matter. But when we're looking up information here, we're using the key of the name, the first part of the key value pair, to find the value in the second part, right? So when I declare this, this is where, the definitions of this, they're multifold. So I want you to pay attention to this. So I can set it up as a dictionary of type string. So it will hold strings, and integers. So really what this is saying is a string, a variable of string. No. What this is saying is that the keys will be strings and the values will be integers. But once again, they could both be strings. They could both be ints. The int could be over here and the string could be over there. It doesn't matter, right? It could be Booleans. Or if you want to go even deeper, you could put arrays in here, or objects or classes, right? But let's just stick with simple data types for now. Strings, integers, floats are good enough. We can also declare it as follows. So you can actually use the keyword dictionary with the angle brackets and this syntax and the constructor. So either one of these, you'll see these kind of interchangeably. I think Swift prefers you use the top approach. Well, the other approach is, and notice the syntax change here, no equal sign there. We say my dictionary, the colon, the bracket, which means it's kind of like an array-like structure. But once again, string is a key, integer is the value. That's the format we're using. And they put a colon inside of it here. This is kind of the indicator. It's a blank dictionary. This is weird, real frankly, like the first time you see it. So if you think of an array, and if we wanted to look up a specific value, right? How would we find a specific value in this dictionary, right? So if scores is this dictionary of key value pairs, right? And we go to scores Ali equals 399. This is kind of weird, right? This is basically a way that we can add a value, right? So if we wanted to add a new key and value pair, I would just call this, the dictionary, name the key, and then insert the value. And what that does is it adds a comma here, puts in the word Ali, colon 399. That's what it's doing. So it's setting up the key and putting in a value and adding to that structure. Another way to do it is to update the value. So if I wanted to change the value of Richard, the value for Richard is 500. Richard is the key. But if I wanted to update the value to 100 for the key of Richard, this is the syntax I use. And look at, I mean, it's intended to read like English, right? So scores, update the value to 100 for the key Richard. So after I run this command, Richard stays the same, but this value changes. So maybe Richard spent some of his savings. He bought a $400 laptop or something, right? So now he only has $100 in savings. Right, you keep kind of ratcheting this up, right? And we can look at print Richard's old value, right? We grab that and we're storing it here. But after this statement, right? And see, this is where it gets weird because now we have a new statement here. You guys catching this? Because now we have this thing called if let. Okay, so this is really weird. I'll be real frank. I still struggle with this one conceptually a little bit because we are basically assigning a constant here based on the previous value, right? And we're storing it and then outputting it. But if this is possible to execute, so in other words, we can get the old value after we set the new value. So if this statement executes, if we can actually do the work, then it will store it. If it can't, then we don't. That's really kind of a strange concept. So this is very, I'll call it very Swifty. You know, this is kind of a weird conceptually. Now, when we are working with a dictionary, and I'll have you kind of like look at kind of the structure of this. Remember what we're looking at is, in this case, removing a value. So we start with Richard 100, Luke 400, Cheryl 800. We can take Richard and set his value to nil. So this is now nil. And if we print it, right, you'll notice Richard doesn't print. Why? Because its value is nil. Interesting. All right. But then we do this statement, if let removed value equals the score. So we will remove the value for the key Luke. So in other words, we're going to delete 400, right? But we're going to store that 400. So we're removing the value, we're storing it here only if this statement can operate. It operates, so the value gets stored here. So when I output, I do get 400. So Luke's score was 400 before he stopped playing. But then when I go to print out the dictionary at the end, remember, Richard's been nullified. Luke has been set. Well, we removed the value, so that's nil too. All we're left with is Cheryl. So when we print the whole thing, we're only left with Cheryl at the end. So it shows that the remove is working. Right. Another thing that is of concern here is like, okay, so how do you access stuff? So this is kind of like helpful, right? So if you don't know what's in a dictionary, that happens, right? So you might import some data, goes into a dictionary, and you don't even know what's in there. So if you're going to like look for something, how do you know what to look for if you don't know what's in there, right? You just don't know. So you can actually do this. You can actually take just the keys and just the values and put them into arrays just so you can see the output. What are all the keys? What are all the values? So you know what you're dealing with. Now, this if let statement again, so we'll go back to this, right? So what this is doing is it looks for inside of scores the key called Luke. So it goes up here, finds Luke, it grabs the value, and now that value gets dropped into Luke's score. Because it worked, it got set. So it's only a let if the whole statement works. And then when we print it out, we get 400. Pretty cool. All right. Then if we run that again and we do another if let, so we look at Henry, we try to look Henry up, and what happens? Well, there is no Henry. So Henry's score never gets set because this didn't work. And so when we go to print it, there's nothing. So it didn't set Henry for us to be able to print it. It just doesn't work. And because it's an if statement, you know, it never will execute. So this is a really unique Swifty approach. I mean, it's kind of like a combination. It's kind of like setting an if statement that tries to do something, and then if it's able to do it, then we do it. This kind of does it both in one step. So you're kind of like doing, like making your if statements shorter really is what's going on here. But we only assign the constant if it's possible for it to be assigned. And really, I think what the strategy on this one is to keep you from making mistakes in your code, right? That's kind of like a error block or something. Right. So that's kind of the overview of arrays and dictionaries. That's actually kind of a bit of information to absorb. When we looked at arrays first, and I'm not sure if we even looked at dictionaries, real frankly, it was very superficial. So we're going a little deeper this time. I'll get the book out of the way. I do have the arrays playground up on the screen, so let's see if we can kind of try to get through this and finish this up here today. All right, so here it says, assume you're an event coordinator for a community charity event or keeping a list of who is registered. Create a variable registration list that will hold strings, and it should be empty after initialization. So now we learned a few different ways to do this, right? So I'm going to use the approach that the author is using in the solution. So he just said variable. And why variable? Because that way we can change the contents, right? That's the why. And we're going to call it registration. Stuff that will go inside of it will be of type string, but inside of square brackets. So we're going to do this. So this implies an array of type string. And right now, you know what? It's empty. So just empty square brackets over here. Right. If I, and there's no harm done here. If you wanted, you could just print the registration list and you will see that it's blank. And what does it output over here? Just empty square brackets. Right. I'm doing that on purpose. That's not really required at this point. They just want us to create it. Now it says your friend Sarah is the first to register for an event, right? So the way we'll do that is we'll just call the registration list. And one way to add something to an array is to append, right? And it's expecting a string, and we're just going to put in Sarah. So we're going to append Sarah to the list. And then if I print that registration list like so, you will see Sarah over here. And notice, once again, it shows us that we're inside of an array. They're asking us to add 4 additional names. So you could do this a number of different ways. You could just take this command and run it 4 times with 4 different names in it. Sure, that's fine. Right? That's one way to do it. So if you wanted, go ahead. Or, and I'm going to show you kind of like one of the other more clever ways. If you know that you're putting in 4 names and you happen to know what those names are, you could do the plus equals thing, and you can feed in a whole array structure. And you see I put in a curly bracket there by mistake. So if I had a guy named Adam and I don't know, Jackie and Seth, Ever. It's my clever hack there, right? And then once again, if we print that out, now we can see the whole structure. So I'm just going to copy that print command and drop it in. And then over here on the sidebar, and I'll make this a little bigger for us, right? You can see that Sarah's still in the first position, and the plus equals just took that whole array structure and dropped it in right after, just as it was. So now we have an array with 5 values in it. The index positions are, of course, 0, 1, 2, 3, 4. The count is 5. Those are all kind of, I think, important tidbits. Next thing that they want us to do is use this insert at method to insert Charlie at position 1. So I'm just going to take the registration list and I'm just going to type insert. And notice the second option here, that's the one that we want. So it says contents of at. That sounds right. So contents of, really, we're just going to put in a string here. And Charlie. And then which position are we adding to here? We are adding at position 1, which would put it, and you can see where it put it, right? So where Adam was, Charlie now is. Everything else got pushed over. Right? And if you want, of course, you can do the printout again if that is helpful for you for seeing how it works. Just do it. Right? I'm hoping that it's not necessary at this point, but it does show you. It does show you in the console too, right? So that's why that's helpful. All right. Then they say somebody had a conflict and decided to transfer registration to someone else. Use array subscripting to change the 6th element to Rebecca and print the contents of the collection. So what we're going to do, right, I'm going to registration list, and then we want to look at something in the 6th position, which numerically is position 5, right? Because we start with 0. So the 6th position is 5, right? And whoever was in position 5, too bad, too sad, they dropped out. Now Rebecca's taking your place. Right? And then, of course, you can do the output of it again to see the results. And you see, so this was 0, 1, 2, 3, 4, 5. Rebecca gets replaced. So there you go. All right. The last instruction here says call remove last on registration list. If done correctly, this should remove Rebecca from the collection. Store the result of remove last into a new constant deleted item and then print deleted item. All right. So this is kind of weird, right? And maybe your brain won't land on this right away, but we can, you know, because we did this whole thing with if let. You guys remember, right? We did all these like if let things. But here we're just going to do the let statement, but we will come back to that if let thing because it is pertinent. We're going to take the deleted item and we're going to go to the registration list, remove the last item, and then it stores it in that spot. And then all we have to do is print it. And now we can see that Rebecca has been removed. This is really kind of a clever technique, right? Because if you're removing stuff, You know, I mean, here we are in a program where we're writing code and it's like, oops, I didn't want to type that. Control Z, right? Where does that come back from? This is an example, right? This we just removed basically Control Z is like removing the last thing that we did. How does it know what we did? Well, it's storing it somewhere, right? And that's what we're doing here. And I think that's really a good example. All right, let's move on to the next page. I'm assuming so far so good.
Yep.
Excellent. All right, this is actually one of the app exercises here. We go back to the whole fitness tracking thing again, right? Which you're kind of getting tired of. But let's see. It says the app shows users a list of possible challenges grouped by activity type: walking, running, calisthenics, etc. A challenge could be as simple as walk 3 miles a day or as intense as run 5 times a week. Using arrays of type string, create 2 lists, one for walking challenges and one for running challenges. Each should have at least 2 challenges and should be initialized using an array literal, meaning you just type it in to the array. And if you want to create more, feel free. So this is how the author is doing it. They're just doing a var. They're creating walking challenges like so. That's going to be an array of type string. And then we are literally going to assign some values. And yes, I am copy pasting to save time. And these are just kind of pulled right from the examples that we were given. So I'm going to walk 3 miles a day or walk upstairs instead of using the elevator. Those are some of my walking challenges. I also want to do running challenges. So I'm going to do var running challenges, also an array of type string. And then once again, this will grab a literal array that they've pre-created for me here in the instructor solution. And I'm just pasting it in to save time typing. You guys should type it in because you don't have a choice. It builds character. So there's those. Now it says in your app, you want to show all of these lists on the same screen grouped into sections. Create a challenges array that holds each of the lists you just have created. It will be an array of arrays. Using challenges, print the first element in the second challenge list. Right, so this is kind of reviewing the syntax. So here's the creation of a new array. We're just going to call it challenges. Right, and notice I'm not declaring a type here because I'm going to populate it with 2 arrays that already exist. One's the walking challenges and the other one's the running challenges, both of which are strings. Right, so this then, if I do an option click on top of it, you'll notice it's an array of type string. And notice the syntax. The string is inside 2 sets of square brackets. It's recognizing it's an array of arrays is what it's doing automatically. So that's pretty slick. Now, if I want to print, right, what did it say? Print the first element in the second challenge list. So in other words, this is what they want printed. Now I could just say running challenges square bracket 0 and it would do it, but that's not the point. That's not how they want us to do it. They want us to use this name to do it. So really the command would be print, and then inside here we'll call challenges, and then we'll print from the second array, which is in position 1, the first element, which is position 0, and that should be run 5 days a week. Right. It says all of the challenges will reset at the end of the month. Use remove all to remove everything from challenges. So for challenges, I just call the name, call the method. Notice remove all is right there. And we'll leave it blank. We don't have to specify. It's just getting rid of everything. And then we can, of course, print challenges like so. And now we see our array is empty. Okay. Now keep going here. There's more instruction, right? If like that's not enough. All right, create a new array of type string that will represent challenges a user has committed to instead of available challenge. It can be an empty array or have a few items in it. I'm going to make mine empty. So I'm going to go var. I'm going to say committed challenges, like so. It's going to be an array of type string. I'm trying to get my square bracket key there. My coffee's in the way of me seeing it, if you guys are wondering. It's like my coffee cup is so tall, you know, because it's right here. It's like blocking my view of a keyboard and where my fingers are landing. And then that's going to be, at least at this point, an empty string array. All right, next it says, write an if statement that will use is empty, which is one of the methods, to see if there's anything in the array. If there is not, we're going to print a statement asking the user to commit to a challenge, add an else if that will print the challenge you have chosen is blank if they chose one, and the array count is exactly 1. So there's 2 things there to check, right? And then add an else statement that will print you have chosen multiple challenges if that's the case. All right, so here's the if statement. Even though we don't have anything, I mean, it's still easy to build things. So the committed challenges, if committed challenges dot is empty, right? Is that true in this case? It is true, right? So what's going to happen? We're going to print, go check out the challenges. You got to pick some, is what they're telling you. Right? Else, if, and why are we doing that? Because we were told to, right? Here, we're going to check to see if the committed challenges dot count is exactly equal to 1. And we're going to output this statement. Prints. Say the challenge you chose is, and then we can use a little string interpolation there, and we can pull out whatever is in the first position, right? That's only if there's 1. We'll take the first one out, and that's the 1. Otherwise, we'll do an else. And then we'll just print out about you have chosen multiple challenges. All right. So in order to really test to see if this is working, obviously, here we're starting with a blank. And so we know the first one is working. So it is detecting that it's empty. But if I put something in here, so if I put like, you know, jump for joy. Then it should trigger the second one. The challenge you chose is jump for joy. See how it's reading it in? Right. And then if we have another thing, I'm going to call it act like a fool. There you go. Then you've chosen multiple challenges. So it is detecting the fact that the array is of different sizes. So either 0, 1, or more, right? So all those scenarios are working. And of course, if I added something else, we'll do something, right? That still triggers the third one, right? So that's how I would test it. So like, but you know, what they're really giving us is this, but I would recommend, you know, if you're putting in these if statements, check each scenario at least once, right? So you want to leave it like this, you know, do it. All right, moving on. All right. Let's move on to this dictionary exercise here. And this one says create a variable string int. And you notice square brackets, so we're creating an array. And this is a dictionary now, right? So this is where it gets a little bit different. So let's do this. Let's try to follow what it says. So we're going to call this days of the month. And you know what? Let's think about this. It can be used to look up the number of days in a particular month. Use a dictionary literal to initialize it with all the months and print the dictionary. Okay. So I don't know if I'm going to do all of it, but you could if you wanted. So I'm just going to call it days of months. It's going to be a dictionary. So we're going to declare the key is going to be a string. The value is going to be an integer. So in other words, how many days are in the month of February? Right? So I would look up February. That's my key. And then it would return the value of 28. Now, real interestingly, today is February 27th. And if you look at a calendar, this year we have a February 29th. So it doesn't, so this is a leap year, right? If you care, right? Normally we don't say it. We say it once every, like somebody's born on February 29th, they have a birthday only once every 4 years, technically. I mean, it's not really how it works, but technically. All right. So here, what they're really looking for us to do, right? And I, yes, I'm copy pasting just for speed, is here's the literal, right? So this is a dictionary literal, right? The key is January, the value is 31. Key is February, the value is 28 or 29, depending. And then March is 31. And I don't know if you guys know this, but I was taught like at a real young age that you can tell how many days are in a month by looking at the knuckles on your hand. And you start like the tall one is 31. So you go January, February is the space between the knuckles. So that's a short month. And then long month, short, yeah, whatever. I'm just putting that out there. Now, if we want to put in all the months, you certainly could, but I'm going to print days of months just so we can see that it is picking it up. And notice it prints both the key and the value. There's no referring to like any one of these numbers with an index value now. You can only refer to them with a key. Right. This is called the dictionary in Swift and Python, maybe in other languages too, but typically we call this an associative array when we're working in most programming languages. And I think of like PHP and Java and languages like that. Right. So now it says using subscripting syntax to add April to the collection with a value of 30, print the dictionary. So what I'm going to do here is I'm just going to call days of months, set up a new key that I'm going to call April with a capital A, and then equal sign on the other side, 30. So I'm taking the value of 30, putting it into days of month under a new key called April. I think that's really slick. Very, very simple syntax. So kind of cool in that regard. So if you print it, of course, you'll see now April is added. Do you guys notice something that just happened though? And I don't know if you guys are picking up on this at all, but when I did this, I did January, February, March. But when I look over here, it's backwards. And when I print it, it's backwards.
Yeah, mine was strange too.
Yeah. Kind of weird, right? And then when I added April, okay, well, following this pattern, it's putting whatever I added last at the beginning, but now April's in position 2. So this is actually a little bit of a secret sauce here. What it's telling you is that Swift is not ordering this in the order in which you're entering it. It's ordering it in the way that it fits into memory most conveniently for Swift, right? And you know what the truth is, if I'm doing a lookup, if I want to know how many days are in March, I don't care what order it's in, right? I'm just doing a lookup. This is kind of an interesting thought here. Yeah, and I don't think the author really talks a lot about that, but yeah, that's the thing, right? It doesn't necessarily go in the same order. Now it says it's a leap year. Update the number of days in February to 29, as if they knew, right? So let's go to days, days of months. And here we're going to do update value. So we'll say update value. What value are we looking for here? And we're going to put 29. So we're going to update the value for which key? For February. So we're going to, so basically what this does is it looks up, finds February. Okay, no, it's not caps lock here. And then it will replace its current value of 28 with 29. Notice in the sidebar how it's still looking at 28 because that's what it's finding in that spot.
Mine says no.
Interesting. Did you got, is your syntax right?
Uh,
Or
yeah, it looks right.
check up here. Is it February colon 28?
Yeah.
Okay. I'm not sure why yours says no. I don't think that's correct, but maybe it'll fix itself when you put the next line in, which is just basically to print days of months. So let's see what it looks like now. But you do see that February did update. Is this still nil for you?
Nope, it says 28th though.
Okay. Not sure what happened there, honestly. Probably intentional by Apple. I'm sure. All right. Next one they want us to do is we're going to use the if let syntax this time. So we're going to retrieve the number of days under January. If the value is there, print January has 31 days, where 31 is the value retrieved from the dictionary. Right. So this is what they mean with this. I'm just going to write a straight if let statement. So I'm going to say if whatever the statement is true, we're going to let January, I'll spell it right though, January days equal the days of the months. And we're looking for the value. And the way we find the value is we call the key, instead of an index number, we use a key now. That will pull back the value of 29, excuse me, 31, right? And then we'll do our output. So we're going to say print January has January days. And then days. January has 31 days. So what this does, right, is it goes to the structure, the dictionary, finds the key of January, and then stores it in this constant, but only if it actually finds it. So for example, if I would change this and I would say July, which we haven't put in there, it does nothing because there is no July created yet. See the difference, right? Whereas if we are finding something that actually exists, like April, well, I was going to say 30 days. That's not correct, but you know, whatever. You know, the point is, it will, if it finds it, it will pull the value back. If it doesn't, then it won't set the constant. That's how if let works. And like I said, I struggled a lot with this concept. It took me a long, like every time I say, I'm like, what is this doing? You know, I just, you know, and I still sometimes think like that. But I think in explaining it to you makes a little more sense in my brain. All right. All right. So the next one that we have is, it says, given the following arrays, creating a new string, right? And notice a new string colon string dictionary, and we're going to call it shapes array, and that should use the key shapes, and color arrays should use the key colors. Now, I think this description is let's call it vague. It's not very clear, but this is what the author means. So they want us to create a shapes array, and what they're thinking is, well, you should know the common shapes, is what they're saying. So let shapes array equal, and we're just going to hard code this as strings, by the way. And we're going to say, what are the basic shapes? Circle,
Square, triangle.
yeah. And you know what? We'll just leave it as 3 basic shapes. Then they also want us to do a colors array. And what the author did was this. They did red, green, blue, which are the three fundamental colors that we use in monitors and electronic work. You know, we create RGB or red, green, blue colors to get what the colors on screen. Now, if you're following along, see, I think this is really not very clear. The way they're doing it is they want us to use now this combination syntax. Now watch how this goes. So we're going to do another let, and we're going to combine the two arrays, but we're going to take the one and feed it into the structure to create just watch. I think it's probably better than me trying to explain it. All right. So we're going to call this shapes and colors. And this will be an array of type string. Same thing they typed up above, but basically square brackets, string, right? And then the value we're pulling back. So string is the key. The value we're pulling back is an array of type string. So when we put in a key, for example, if I say shapes, it shows me all the shapes. If I say colors or ask for colors, it shows me all the colors. This is actually, this seems like why on earth would you use this? You know, it seems kind of dumb. But think about like if you're in a program and you're running a program and you get to like a dialog box and it's like, oh, you chose shapes. Okay, well then it loads the list of shapes from a list and puts it in a box, and then you can select your thing. So it's actually very useful structure. So the way that we build the actual structure here is on the right side. We'll use the key of shapes, which is the actual we'll call it the symbolic name of the shapes array, and that key, when somebody uses that word, will point to the shapes array. Okay. The next one is we'll create a name called colors, which will then point to the colors array. Right. Now, the only way we can really see what this does, by the way, is to do a print. So we'll just have to do print, and then in parens, shapes and colors, and watch the output here. Pull the panel over so you can see it all the way. I guess that's as far as I can go with the panel. But you see, so I called shapes the key, and then it pulls back a whole array. I call colors the key, and that pulls back a whole array. And the whole point of this really is that you can have dictionaries whose values are arrays. The keys have to be singular, but nobody says that the value has to be a number or a string. It can be, folks, it can be anything, really, that's allowed. In this case, the key shape points to the shapes array. The key colors points to the value, or the value of colors array. So I think that's really kind of an interesting little feature. All right, so one last little task here, and I'm going to just kind of like put this terminology in there, this unwrap concept, right? And this is maybe the first time we're really thinking about this. It's another one of these concepts I'm still wrapping my head around, real frankly. And just kind of watch how this goes. And it says, print the last element of colors array, accessing it through the dictionary you've created. You'll have to use if let syntax or the force unwrap operator. And this is what I'm going to kind of, you can use it either way, basically, is kind of the thing. To unwrap what is returned from the dictionary before you can access an element of the array. All right, so let me just show you what I mean. All right, so we're going to first do if let. We're going to do colors. And then what we're going to do is we're going to point to the shapes and colors array and we want pull this to colors. That's what we, what we're calling for. So we're gonna search for the key of colors, right? And then if we find it, right, if we find it, then we're gonna print. Now keep in mind here, when we run this, what it's really doing is it's going in there and it's finding this, and then what's inside the array gets stored here. And so then if I want to access green, for example, in my print statement, I say colors 2. Now they call this an unwrap. Okay, so really what we're doing is like we're going into a complex object, we're pulling out a complex set of information, putting it into a different object, and then accessing a particular piece of information from that object that we just unwrapped. So we went into like really a complicated dictionary structure, pulled out a complicated structure, found a specific piece of information and unwrapped it and put it on the screen. So that's kind of the, we'll just leave it at that. But you can see how that works, right? So if we go to colors position 2, this is being stored now in a regular array, which does have an order. And for me, well, it's saying blue. Well, that's kind of interesting. Maybe, the other thing that I could do is I could just print. Oh, why is it saying blue? Well, we don't know what the order is. So if we just print colors, now I can, oh, and I'm doing it on the wrong.
Yeah, I was gonna say you're not typing in.
Yeah, I'm typing into the instructor and I probably shouldn't do that because then it's changing the answers, right?
It still didn't go.
Yeah, this is the problem with too many screens, right? But if I do want to see everything that's in there, I can just very simply do colors, right? And then I can see the order, and you can see I broke it, right? Okay. I'm just firing on all cylinders here. But that's okay. I can't be perfect every day, right? So when I go to position 2, which one is position 2? Well, now we use standard array numbering. So that's 0, 1, 2. Blue is the third one, right? But that's position 2. Right? So I think that's helpful. I'm just doing this part just as kind of like reference. So if you don't know what's in something, you can do a print command, just put it on the screen and go, oh, that's what's in there. Got it. Right. And that helps. All right. Last page here. And by the way, once we finish this, we're going to call it a day. That's a lot to absorb in one day. A lot of heavy.
It is.
It is. I know it is. All right. So let's take a look at the topic here. And it says, these exercises reinforced the concepts in a fitness tracking app. Welcome back. And it says, in previous exercises, we wrote code to help users with run pacing. You decide that you could use a dictionary to let users store different paces that they regularly run at or do interval training with, right? So we're going to create a dictionary called paces of type double. So correction, key, string, value, double, and assign it a dictionary literal with easy, medium, and fast keys corresponding to a value of 10, 8, and 6. Notice the point zeros after each one. These numbers correspond to mile, pace, in minutes, and then print the dictionary. Okay, so I mean, not really that difficult of a task, but it's more in the reading of it that makes it difficult. So we're going to start with a var. We're going to call it paces because they said we should. And then we're going to set up an array. So I'm doing curly brackets and square brackets. And then inside there, the key is going to be a string and the data or the value is going to be a double. That'll be our key value pair. Over on the right here, we're going to do the values that they talked about up top there. So the first key would be easy, corresponding value of 10.0. Then we'll do medium. I should be consistent here with my capitalization. And then its corresponding value will be 8.0. Another comma, Next key value pair is fast. Corresponding value is 6. No. Right. Then they want us to output this. So we're going to do a print. And we're just going to print that we just created. Let's take a look at the output here. You can see it on the bottom of the screen. You can also see it in the sidebar. Once again, ordering makes no sense, right? Because it's not ordered by index value. It's ordered by memory location or whatever it is. Now they want us to add a new value. Well, we've done this a couple times now, I think. And we'll say paces, and they want it to be called sprint. So here's my square brackets, and inside here is the new key. The new key is sprint. That's spelled correctly. And the value that we're putting in with it is 4.0. Now, and I'm wondering if this is like a running pace. So they're saying like if you're sprinting, it's a 4-minute mile. That's kind of what I'm reading into it. Or if you're kind of fast, 6-minute mile. If you're really slow, it's an 8-minute, etc. Or if you're walking, it's a 10-minute mile, or maybe 20, something like that, I think is what they're trying to do. Okay, so this adds a new key and a new value. We can prove it by just printing it out. So let's do that. There it is. Now you can see it in the sidebar. You can see it at the bottom. Right, so that's our new key and value added to the dictionary. Right, now it says, imagine the user in question gets faster over time and decides to update his or her pacing on runs and updates the value of medium and fast to 7.5 and 5.8 respectively. Print the dictionary. Okay, so really what they're having us try to recall here is, how do I change the value, right? And so one way you can do it is like this. So I'm going to do both ways, right? First way is I can use the update value thing, and I'm going to update 7 to 7.5 for fast. For which key? Fast. So see how that helps you, right? This is, which key are you doing this for? Fast. Right? And actually, I think this is for medium. Read it correctly. So 7.5 for medium, right? I also want to change fast. Another way to do it is you can just call it by its key. So I can call fast like this and simply just change its value. So I can just type 5.8. Both of them changed values. Now, if you ask me which way would I normally do, I'd probably do the second way, because that's kind of how I do it with other languages. That's what I'm used to. But the top way is pretty cool too. And I'm not sure if there's an advantage to one approach or the other. You can experiment. All right, and then print it out on the screen, and you can see fast changed to 5.8, medium changed to 7.5. So both of them were effectively changed. Right. Next task here says, imagine the user in question decides not to store sprint as one of her regular paces, right? So remove sprint from the dictionary and then print the dictionary. All right, so we can do this a couple different ways. Because it's not an ordered structure like an array where it has a number, I can't say remove last, because sprint is the last thing we added. Because when I look at the structures that they print out, it doesn't print out in the order that I did it. So that would be wrong, right? And I don't know if there is even a remove last, honestly, but we do have a remove value for key. Which key are we removing? We're removing sprint. And by removing the value for sprint, we're also removing the key for sprint, right? So now if I, once again, print this, take a look at the output on this, sprint is gone. And you can see it down in the console too. It's just gone. Right? If something, and this is important, right? If we're using key value pairs and either the key is missing or the value is missing, it's incomplete. It's not a complete piece of information. Requires both pieces to be valid, right? Key value pairs. Another thing I will kind of add in terms of like why key value pairs are important. It's become kind of a real prevalent way to move information through applications. So one really common technology being used out in the field today for moving data from one application to another, from a database to an application, is a format that we call JSON, which is JSON, which stands for JavaScript Object Notation. And all of that information is transmitted as key value pairs. The syntax is a little bit different, but the concept is the same, right? You have a key and you have a value, and the data travels that way. The thinking is, if you're only transmitting one piece of information, it not only has the values that you want, but it also has the definition of the structure of the information too. Because if you think about this, the key tells you the running style, and that tells you the value. So it kind of gives you a breakdown of the information as the information is transmitted, as opposed to like if you just got an array of values and you didn't know what they were, it's like that means nothing, right? But a key value pair, because the key hopefully is sort of descriptive of the value, you can associate the information and what it belongs to. So that's just kind of a helpful aside, let's call it. All right, last little tidbit, and then we're done. All right. When a user chooses a pace, you want the app to print a statement stating that it will keep him or her on pace. Imagine a user chooses medium, then accessing the value from a dictionary, it'll print a statement saying, okay, I'll keep you at insert pace value here, etc. All right, so that's what we're really trying to do here. So this is going to be in the form of an if-let, if you haven't figured that out yet. So we're going to reach into the complicated object, pull out an information, in other words, unwrap it, and then display just that piece of information. So we're going to do if-let pace. So this will only populate if we can find the information. What information are we looking for? We're going into the paces dictionary, and we're looking for the value named medium. And if that works, right, then we will print out this statement that's something to the effect of, okay, I'm trying to follow what they have up there. Okay, exclamation. I'll keep you at a whatever pace we populated, minute, mile, pace. So it is going into that list and finding median and pulling back the value for medium, which is 7.5. We can see it in the console, populating that spot, right? So it only sets the value of 7.5 here if it can find the key of medium. To give you an example of it not working, which is the one that we removed, sprint. So if I look for sprint and it doesn't find it, notice now on the sidebar it's printing nothing. We could also have an else. So we could, and so people do ask this. They'll be like, can you put an else in there? And you could just say print, sorry, value not found, or key does not exist. Really, both are true. If you don't have one, you don't have the other. You can't have a key without a value, and you can't have a value without a key. Right? Now, if I switch this back and I put it in a different one, so if I make it fast, right, that will put the 5.8 minute mile pace in there. So I think this is an interesting approach. This process here is called unwrapping, right? And like we're going into a complex structure, pulling out a specific piece of information only if it's there and it's valid. Then we're putting it in here if that's true, and then we can have a customized message based upon it. Otherwise, Yeah, you can do an else. That this part's not required. We weren't asked to do this. I just did it. Right. Did this work?
Yeah, it worked.
Fantastic. All right. I'm going to stop the recording here. We did complete the structures playground all the way through. I'm sorry, the collections playground all the way through. All right. And the recording ends here.